Deep,
What's up?
how you doing?
Doing well. How are you, Charles?
Great. So hey, listen, I just recently, I'm new on the team, but I recently just found out that we support Java sort of first class. I mean, I know I've heard it. Well, thanks,
You did well.
And I'm really curious, like, how did we pull that off? So talk to me about today.
Yeah, so as some of you guys on the other side of the camera may know, we have invested in having a great experience for our .NET developers, but we've also invested a lot into Java because there's a lot of you guys out there that are experienced Java developers, and we want to make sure that you can take advantage of Service Fabric as much as possible. So that means bringing things like reliable collections, which some of you now might be familiar with from our previous videos, into Java and making that available. So with that, I have a special guest with me here today with his cup of Java. What's up, Pavan? How are you doing?
I'm doing good, Dave. How are you?
Good. So can you introduce yourself a little bit for those of us that haven't met you?
Sure. I'm Pavan. I primarily work on Java programming model and I work from IDC.
Cool. So for those of you that don't know, IDC is actually our office in India, in Hyderabad, right?
Yes.
So that's awesome because if you may have remembered from one of the first videos Charles forced me to put out on the internet, we have developers that are in the US, in Redmond, but we also have a team in Serbia and we have a team in India. And Pavan is one of the guys that works out of our India office. Right. And at big Microsoft conferences, people from the teams tend to come and gather out in Redmond. So you've been out here for about a week or so because we had Build last week.
Yes.
So how's your trip going?
It was really great.
Yeah.
Build conference was really great, amazing, and meeting folks around here has always been good.
Yeah. Awesome. Did you have a good time?
Yeah, of course.
Yeah. How do you like the office here? How does it compare to what you have in Hyderabad?
Yeah, I basically like the pantry.
Nice. I can see that. Yeah, I can see that. Cool. So you've been spending a bunch of time now working on Java. How long have you been on our team?
More than 2.5 years.
Cool. And you spent most of it working on this
Java.
Perfect. So you're the expert. You're the right guy we need to have in here. So we'll spend some time, I think, focusing more on how you were able to make the things that we were able to do for .NET available in Java. And then we can talk about like where we're going to take it in the future.
Sure.
Yeah, so tell me a little bit about, paint the picture a little bit. Tell us about how Java works, why it's different than .NET, why we needed to invest in making sure we could provide the same programming features, models, frameworks in Java.
I'll go into a bit of history. When we invested our efforts to bring Service Fabric runtime to Linux, we had an option to pick a language.
Okay.
And naturally, Java being one of the popular languages out there, we picked Java. And Coursera was also not around that time, so we picked Java. Then, unlike C#, C# talking to runtime does all the marshalling stuff and something like that.
Okay.
But Java doesn't do that. We need to write our own JNI layer. I want to speak a bit about that architecture. How did we achieve that?
What layer, sorry?
JNI, Java Native Interface.
Cool. So what does that mean?
It's an interop layer. It allows managed language like Java to talk to runtime.
Makes sense.
Yep.
Okay, so let's talk about it.
It basically does all the conversion logic, like data type conversion logic and stuff like that.
Okay, so do you want to use a whiteboard?
Yeah.
Let's do it.
We have Service Fabric runtime, which is completely written in C++. And this layer exposes its interfaces in the form of COM, right? And we have a layer called JNI, which is...
We're losing the whiteboard.
Okay, it's the interop layer.
Yeah, cool.
I think I should change the marker maybe.
Okay, we'll
let's get
go
him a
green.
fresh one. Go green.
Go green, brother.
Go green.
Or blue, it's up to you.
That works. Cool.
Great.
And
There we go.
we have Java over here, right? In order for Java to talk to C++, we need to write our own JNI layer,
Okay.
right? And JNI can speak to Service Fabric runtime using the COM layer, right? Now,
What do you mean by COM there?
the COM layer is something like, let's say you have a method, which takes complex data types and stuff like that, and which not every language understands. Basically, you need a common layer which is accessible for every other language out there, right?
Sure.
Like basically, all your function definitions are in how should I say, like the basic types, right? Like you have simple pointers, and it will not throw any exceptions. It will return H result, and using H results, you need to understand whether your method returned without failure, or your method failed and stuff like that, right? And I'll talk a bit about the lifecycle methods. For any replica to come up, we need to complete the lifecycle methods, right? Let's talk about OpenAsync, for instance.
Okay.
Right?
So do you want to start perhaps with on this side what the action is that SF runtime is taking, and then let's work our way back to see how that looks in Java.
For hosting to complete your replica's OpenAsync should get completed first, right? Now, runtime should call JNI, right?
So we're looking at OpenAsync right now, specifically.
Exactly.
Let's
Let's
do that.
talk about
Okay.
OpenAsync, right?
Yeah.
Here you have, let's say, OpenAsync, which is Java method.
Okay.
And all this guy knows is I need to complete OpenAsync, right?
And this is the same C++ runtime that would be the, regardless of whether or not it's Java, it's the same thing that's actually happening in Service Fabric.
Exactly.
Which is how we're actually processing that commit successfully across all replicas.
Right.
So for those of you that want to learn more about that, I would say go check out Sumuk's video, which we published a couple of days ago. And you learn a little bit more about how this sort of works. Yeah.
Right. Now this guy calls into this layer, and this layer calls into JNI, and the JNI calls into the replica objects. Write a little bit bigger. Replica PLICA. I'm sorry, my writing is bad.
That's fine. We understand what you're saying.
Right. Now the question is, how does JNI know which object to call? There could be a bunch of objects, right? How does this guy know which object to call, right? And
so when you say which object, you mean of the set of available replica objects.
Exactly.
JNI needs to be able to communicate with the right replica
like there could be any number of Java objects. This guy doesn't know which object is replica object, right? There is no flag on any object saying this is replica object. This guy doesn't understand what is replica at all, right? This is plain Java, and this guy doesn't understand what Java object is, right? Now we use something like broker pattern. Okay. When we register a service, we create replica object, right? And we register that replica object with JNI, right? And JNI registers itself with runtime, SF runtime. Now, all this guy understands is C++ objects, not the JNI objects, not the Java objects, I'm sorry, right? Now, this guy registers itself means that this guy registers a C++ object with the runtime.
Okay.
And this guy calls into the C++ object, and this guy calls into the Java object, because this guy understands what Java is.
Right.
Right. That's how it happens.
So it's like kind of like a middle translation layer between C++ and Java.
Exactly.
Okay, and I know some of us know what the broker pattern is, but for the people that don't, could you just talk a little bit briefly about what that is from a high overview?
Yeah. Should I? Wait.
No, just talk about it for like a sentence or two, so people understand why this looks like a broker pattern.
A broker pattern is nothing but, you call into something, and that acts as a proxy, and that guy calls into something else, right? That acts as a broker, that basically delegates your operation to something else. That's what we call broker pattern, right?
So in this case, your JNI is what you'd call the broker, where you're registering each replica object, both from the Java side, but it also has knowledge of the C++ side.
Exactly. Yeah. Exactly. The implementation of something like iStateful service partition. iStateful service partition is the broker over here, which registers Java object with itself, and iStateful service partition's implementation is registered with runtime.
Okay. So what happens now when we push updates to SF runtime? Because we're obviously modifying things about how we manage replicas. We might be making changes in replica management, but also in things like reliable collections and stuff. So every time there's a change in the runtime in the C++ code, we obviously have to do some stuff to make it workable with C#. How do we keep the JNI up to date?
Okay. I would talk a bit about the repos over here. We have runtime code in a different repo, which is Windows Fabric repo, and we have Java code in a different repo.
Okay.
So, in order for our code to build, we need to get the bits from SF runtime to SF Java repo, and we need to build against the bits which we got from here. And if everything goes smooth, if compilation and linking goes smooth, it means our code is at a position where we can test it, right? When there is a breaking change in SF runtime, right? First we need to get the headers and bits from here, right? Libraries from Windows Fabric repo to Java repo, right? and we need to update our JNI layer. That needs to be done because this guy directly implements the headers of SF runtime.
Right.
Right. Now JNI layer needs to be updated, and in some cases even Java needs to be updated because the relevant operation, right? The relevant function which got changed over here might be affecting Java layer as well. So we need to be updating that, and we need to be updating our code base, and we should be testing it. Then we'll be publishing. That's
Okay.
how it works.
So this leads to sort of my next question, which is that obviously means that between us adding something to the C++ runtime, there's obviously going to be some kind of amount of time that is spent to make sure that it's actually working for Java before we can ship like the Java SDK, from which people will then be able to take advantage of whatever changes we've made to the runtime.
Can you repeat the question?
So how long does it take for us to go through when we add something new in runtime to be able to then take advantage of it in Java code?
The code freeze date of SF runtime will be much ahead, right? Much ahead of Java repo.
Exactly.
Right. That way we can use that buffer to get bits from here and test ourselves.
So that's how we're able to ship at the same time.
Ideally, we should be shipping at the same time.
And today, from what people can do with the Java SDK, what is it completely on par with what's available in C#, or are we still catching up?
There are some things which are not there in Java repo, like the client library, right?
So let's talk a little bit about what's there and what's not there.
Sure.
Yeah.
From what's there, we have stateless services, right? I'm not going into details of programming model. We have stateless services, we have stateful services, and we have reliable collections. And in reliable collections, today we support only reliable hash map, which is equal to reliable dictionary.
Right.
We don't have reliable QL, right? And that is something what's not there. Reliable queue is something what's not there. And we don't have we don't have client library even. The reason for not having client library is we came up with something like Swagger library, wherein you can generate your own client library and work with it. So from the maintenance perspective, we need not maintain client libraries for every language projection. Instead, we could be using Swagger.
That's pretty cool.
So the cool thing about Java hash maps is they're super performant.
Yeah.
Right? So when you go to your job interview and somebody asks you an algorithm question that involves manipulating data and understanding things and moving things around, always use hash map.
Right.
Always, without a doubt.
Right.
Super fast. So what about the other collections that we don't yet support? Is there a plan to support
Yes,
the current
we do.
queue and stuff like that?
We do have a plan to support reliable queue in future, but today we support only reliable dictionary.
Okay.
Right. I would like to talk a bit about reliable hash map.
Great.
Right. Now think of reliable hash map is something like distributed concurrent hash map.
Okay.
Nice.
Right. It's a distributed dictionary and it's concurrent and it's a hash map. Okay. Now reliable hash map was written on top of T-store, which we discussed with Preetha last time.
Yes.
Right. Now I just want to talk a bit about T-store architecture.
Okay.
We have T-store, and I would not be going much into details of T-store.
Watch the Preetha video for that.
Yeah. Watch Preetha's video for that. Yeah. But I would like to tell one thing about T-store. T-store was written using coroutines. Right?
Charles' favorite
Yes.
thing. Yeah.
Right? What basically is coroutine? This is completely async model bringing into C++, and this guy understands what async is, what await is, and stuff like that. But these language projections need not understand what coroutines are, right? Now I have my JNI. And let's say add async, right? This guy returns me task. Now this guy need not really understand what a task is, right? Now what do I do for it? For this thing we exposed a layer called C layer, what we call C layer. This guy translates all these tasks into callback pattern, right? Now JNI registers a callback. JNI registers a callback with C layer, right? If this particular operation, add async, didn't complete synchronously, if it's an async operation, then C layer will take care of calling the callback and completing it asynchronously. That's what we did. Let's say you you are using Node.js or for that matter any other language, which
Sure.
You need to write your own interop layer, right? Now you need not take dependency on the coroutine implementation. This coroutine implementation could be anything. That could be internal to your repo, right? And you cannot take dependency on what coroutine is. So we need to expose something which is similar to COM again. Now this guy needs to return me H results, and this guy should not throw any exceptions. This guy should accept only basic types as parameters and stuff like that. For that reason, we came up with this C layer. Right now, any language can take advantage of T-store.
And the neat part about this now is we can start with, like you said, the C layer gives us the option of then saying, you don't have to be developing in C# or in Java in the future to be able to take advantage of our highly performant concurrent data structures that we have in the T-store.
Right.
And the goal is to sort of make that available for other people in the future as well.
Right.
So we should be talking about that at some point.
Right. When someone wants to take care, leverage our T-store, right? Then they could directly call into C layer. Now, any language that can call into C++ can call into C layer and can take advantage of T-store implementation.
What I want to know is how hard is it for somebody to go and say, I'm really passionate about some language and I want to build my own set of interaction with the C layer and with this.
From the reliable cultural perspective, it's fairly simple.
Okay.
All you need to write is your, small layer wherein you would be writing something similar to Hashmap, and you would be calling into C layer directly, and you would be getting back the result. And if your language requires you to write interop layer, you would be writing that interop layer. It's fairly simple.
Awesome.
It's pretty neat.
Great. So folks, start building language projections.
Yeah.
Come on, and then
It's
share
so
them
easy.
with us. Share the language that you supported.
Yeah.
So let's keep going. I mean, there's a lot more to this for the Java developers out there. I mean, you had to keep, when you're a programmer in a certain model in a certain language, there's a certain style, right? There's a certain way that you're used to programming, and things make sense to you. So let's talk a little bit about how you maintained the Java just the Java experience when building your consumable APIs.
That was one of the tough tasks, As in, we have T-store and we have C# as a reference, but still we wanted to make it look Java-ish, and so we took Hashmap as a reference, and we kind of exposed the APIs, whatever is needed for the user, right? And something like, we have compute async, right? This guy takes the input, then computes the result and gives it back to the user. This is equivalent to compute in Hashmap, just that you have async in the end to represent it's an async method, right? Now, a Java developer can work in a way he's working with Hashmap. It's more or less the same way, just that instead of returning the result directly, we are returning you the future, computable future, and he should be working with that future. Now, a service developer can opt to write his code in a synchronous way, calling it on that future, or he could change the futures and write his code in a asynchronous way.
Yeah.
Right? This is more Java-ish, I would say that. And we carefully evaluated all the options, and we made sure our reliable Hashmap looks very similar to Java Hashmap.
Interesting.
And now we're going through the process with the queue, right?
Yeah.
Yeah. So where are we with that? How are we thinking about it?
We haven't started on that, but it will come in the near future.
Okay.
We haven't started on that. Yeah.
And what about the tooling support, right? People aren't going to be using Visual Studio.
Right.
Well, I guess they could use code if they wanted. We support Java now.
But it's all about
Talk about tooling, exactly.
Yeah, Eclipse, right? Eclipse is
We have, in the initial days, we had written something like Human Generator. It's a CLI tool. It
Right.
generates templates. It's a simple tool, very simple tool. It generates templates, and you should be able to use the application which got generated and deploy them, right? Based on that, we written Eclipse plugin, which also generates these templates for the application package. Along with that, this guy is able to deploy, undeploy, upgrade applications, right, on the local box or on the remote cluster. Okay. And also we have CI/CD Jenkins plugin, and GitHub supports Jenkins, and we leverage that. And whenever there is a change in the code base that we push, this guy builds the code automatically and calls the post build script what we have. And This guy uses the cluster URL, what we inputted over there, and takes the application package, deploys. If the application package is already present, we took care of those basic cases. Like if the application package is already present with the same version, we undeploy it and redeploy the application. If the application present over there is of a different version, we upgrade the application and probes the health and see if the test passed or not. If it passed, then we are good to go.
So you're probing the work of the great Awana, who was on just yesterday. Health manager. That's awesome. And her code's gonna come back to you and go, healthy, not healthy, here's maybe why. Cool, man. So again, like if I'm not an Eclipse user, right? And I want to use, say, a JetBrains product, which is kind of a killer Java product. How do I do that? Can I do that? Do I have to rely on Microsoft and your team to provide me with the plugin, or can I just do it myself?
You can write your own plugin, but we do have plans to support something like IntelliJ. IntelliJ is also one of the popular IDE out there in Java world, so we do have plans to support IntelliJ, and we do have plans to support Java on Windows.
Oh, that's a great question. So Java by design, because of the JVM, is write once, sort of run everywhere. Can you, please do elaborate on that. So we're going to support Windows.
The Eclipse plugin, what we had written, is not platform agnostic.
Okay.
We need to solve that problem, then we are good to go to support Java on Windows. Basically, getting our programming model onto Java doesn't come with any challenges, right? There are, of course, challenges, right? Because we support completely async model. I'll just...
Okay.
Yeah. Here we have something like begin X and X, right? And you have something like, something like my method X, right? This guy needs to call begin X, and this guy needs to pass the Java context, and when the method is completed, this guy completes the context, and this context in turn completes the future over here. You understand what I'm talking about?
Yes, 100%.
Right? Now, we have Java in between, and we have JNI in between. Now, this guy needs to intimate JNI that I'm completed. Now, you can go ahead and complete the future. Right? Now, this guy needs to talk to runtime and complete it. Right? Now, we ran into a bunch of race conditions there. Right? Sometimes your future will never get completed because of a race condition. Right? Debugging those were
challenging.
Tough tasks actually.
Absolutely, man.
Hopefully we fixed all the race conditions out there, and we are not running into any race conditions in any of our tests. All our tests are perfectly working fine.
Great. Awesome.
And from the logging perspective, we didn't use the Java default logging way because we wanted our runtime logs and programming model logs at the same place for better debugging, right? So we write our logs into the same LTT in the sessions opened by the runtime. That's one thing we do, which is a bit different from what traditional Java developers do.
Okay. And can you dig into that a little bit more? Why is it different?
In general, any Java developer would be using a logging library, right? Like
Log4j.
Yeah, Log4j or SLF4j or Logback, right?
Understood.
That would be writing logs into your destination, whether it's a file or remote log share or something like that. But we wanted our runtime logs should be along with the programming model logs, right, for better debuggability, right? Like let's say a runtime called OpenAsync and OpenAsync failed.
Yeah.
Right? If these two logs are not at the same place, how do you debug it? That becomes tough for us, right? We need to match the timelines, and we need to, if they are at different places, we need to match the timelines and see what happened there. Right? If they are at the same place,
Sure.
it becomes debugging much easier, right?
But now, when somebody develops in Java, they're going to probably use a logging library like the ones that you mentioned. So if you have your application that's writing out logs to Log4j or whatever other logging library you choose to use, that application might be using Stateful Services. That stateful service will write its reliable services events or whatever to LTDNG, which is where the service traffic events will also be.
Right.
So at some point, they might have to do correlation anyway, right, across all those things. So is the recommendation then to also write to LTTNG or?
No, we don't support that. When a service developer wants to write their own logs, they need to use their own logging mechanism. They should not flood our LTTNG sessions with their logs. Now, there could be a rogue client which kept on inputting logs and which could crash our system.
Sure.
Right? We don't want to do that.
And
now,
then,
Yeah, our stuff is not open for writing from user code.
right.
Right.
My next question to you is, if somebody wants to view their interactions with the runtime, so whatever reliable services and stuff they use, that stuff is coming out as LTTNG. They're writing their application, say, I'm most familiar with Log4j, so I'm just going to say Log4j. So I'm writing an application, I'm a developer,
Yes.
I use Log4j.
Yes.
I want to see how my application code is interacting with the runtime, so that it's doing that through the reliable services and whatever JNI stuff that we've implemented. Can I redirect that data to not just LTTNG? Do I have that option? Is that something we're considering?
You're talking about the programming model
Yeah,
also
if
somewhere
there's
else?
yeah.
No, we don't have that.
So what would be the recommended way to get that? Would I add my own instrumentation? So I would duplicate the data, so basically have one tranche going to Log4j?
Yeah, you can do that. You can duplicate your destination for logs. You know, the programming model logs can go into a file, and then you can see what's happening, how the interaction is happening from your service code into the programming model, and you can correlate.
Cool.
What's happening. You can understand what's happening there.
So one of the things that's always fun to quickly discuss would be like whenever you create sort of a new programming support on top of an existing runtime, sometimes that'll add to evolution and improvements in the underlying runtime to support your needs. So what kind of changes, were there any changes that were necessary to the Service Fabric runtime and associated friends to enable the creation of this Java projection?
Not anything I can think of, as long as
Impressive.
That's cool, right? Because that means now for other languages we don't have to, ideally at least.
Yeah.
Yeah.
yes, I can't think of any changes that runtime needs to do in order to support any language projection, because COM layer by design they are language agnostic. Now any language which supports talking to C or C++ should be able to talk to that layer.
Okay.
Right.
I can think of a number of languages that will meet that requirement,
Right.
especially some popular ones.
Are you excited for the future, Charles?
Yes. I'm stoked that Java developers are like completely supported. Completely what I mean by that is they can use reliable collections, they can be stateful, they can be stateless, they can do the basic things that you need to do to write a highly capable Service Fabric service. And get all of that goodness from the runtime underneath on their favorite platform, which of course is Linux. Which is, just increasing in popularity for good reason. So, what were some of the hardest problems that you had to solve as an engineer, talking to your fellow engineers? What were some of the really hard problems that you really kind of had to crunch on to make this happen, for you personally?
To make this happen, as in debugging race conditions has never been easy. That's my, as in, after debugging some race conditions, they became one of my best friends, Now I like
You hung out with them
debugging
all the
race
time. Yeah.
And so, how did you do that? What were some of the tools that you used? Like, did you use?
Actually, can you just walk us through an example?
Yeah,
If you have something that comes to mind.
Since they're your friends.
Tell us about one of the race conditions that gave you a lot of pain,
Okay.
how it came about, and how you dealt with it.
Okay. The recent one which I can recall is actors by design, they are single threaded, right?
Add task?
Actors.
Yes, actors.
Right?
Yeah.
Now, let's say you are doing some performance testing on actors, and somehow one of the actor is performing slow, and which took a lock, right? And which is not, which took a lock on that particular actor, and the other clients are not able to lock that actor, right? Now, by default, completable features, right? By default, completable features spawns n number of threads where n is equal to number of cores on the machine, right? That I wasn't aware of, right? Now my tests were failing with the timeout exceptions, because one client actor is sometimes actor is taking more time because of whatever reason, and the other clients are blocked, and the other clients fail with timeout exception. Now I had to use a JProfiler to see how many active threads are there and what's happening with the threads, and all the time I see the number of active threads is equal to number of cores, right? Now I was surprised, there are not many threads, there is no thread spike at all. But what's happening underneath? Then I did a lot of reading on internet, then I figured out, okay, also I looked into the completable feature code base, right, Java code base, then I figured out, okay, the number of cores is equal to, the number of threads is equal to number of cores by default. So what we did was to fix that, when you are taking a lock on the actor, you spawn a new thread, which is not completable feature thread, right? You create an executor and spawn a new thread. Now, a completable feature has a spare thread to allocate all the time, right? Now this guy can spin in 8 threads, and whenever you are taking lock, this thread will get released, and a new thread from the executor will be spawned, and the spike what you see is on the number of threads on the executor, not on the completable feature. Completable feature is never choked now.
Because that's still the set based on the number of cores that you have.
Exactly.
Okay.
Cool.
That's one thing, and the other thing was like, timer tasks, right? We allow users to register a timer and do some operations, right? On the actors, you can
Like a schedule.
you can schedule a timer and which does tasks, right? Once in a while. Now what happened was we have this service fabric partition client wherein you have a timer, and this timer keeps track of all the clients which are active, and if the client is not active, there are no active connections to the client, it will go ahead and garbage collect it. Now this timer, we create this timer as a background timer, and this background timer thread will not get killed when your object is gone. That thread is always active, right? Now the number of threads spike.
Got it.
Now when you have more clients, your number of threads spike, and that consumes your heap, and your application will crash with heap dump, right? Out of memory exception with a heap dump. Then we had to analyze the heap dump and see what's happening with the threads over there. Then instead of creating a timer thread for every service fabric partition client object, we took that code out, and we create only one thread which looks for all the clients, and at any point in time you have only one background thread which is doing that operation instead of n for n clients.
You got it. That's great. That's a great optimization. So for the JVM people out there, we support you. We love you, right?
Yeah, we're fans, and we want to continue enabling you in the future as well. So as Pavan mentioned, we have some gaps, but we're working on plugging them, and we want to make sure that we have a first-class experience sort of for Java and other languages in the future as well.
Absolutely. And so for your fellow Java programmers out there who are watching this, how did they get started pretty quickly? GitHub, we have some samples.
Yeah, we have all the documentation which is required out there, and we have enough GitHub samples, and we will be adding more samples into the GitHub. Also, you can look into how you can create application package using Eclipse, and you can see how you can deploy. And also, we are coming up with something like Service Fabric Mesh, wherein you can use reliable collections in a simplified programming model way. It essentially means that you need not change much in your application, right? Instead, you can get the reliable collection context, and you can work with reliable collections within your process. So now you need not do a network hop in order to get your data. It's in the same node where your container is lying, right? Now all you need to do is you need to import R jar, and you need to reference reliable collections in your YAML template. That's not yet there. That's work in progress. We are going to come there soon.
That's awesome. I mean, Mesh, we learned about it for the first time.
A week ago.
Service Fabric Mesh. Service Magic Mesh. So
you're having too much fun, Charles. You're having way too much fun with
So
this.
talk to me. I mean, this is actually awesome because it's really exciting to not have to worry about cluster management.
Right.
Yep.
So the whole point of Mesh is sort of to abstract away like all sense of infrastructure. And with that also means we couldn't just port the same programming paradigm that we had for Service Fabric today and just move that to this sort of new environment. So we expect developers who are targeting mesh to deploy and build applications that they don't need to have a dependency or understanding of how the cluster is actually running underneath. So what that means is we have to do things like what Pavan was saying, where reliable collections doesn't have to be so tightly interlooped with your application anymore, where instead it can run as a set of interfaces alongside your processes, where you can then reference the reliable collections from any of your running applications via the same common interface. So what that does is, one, it makes it easy to run in an environment like mesh where you don't need to have tight integration with your infrastructure. But two, that also makes it really easy to integrate reliable collections into your applications, whether they're .NET, Java, or any other language. Building a set of generalized interfaces means you can more easily, without having to alter your code, take advantage of them. Today, if you look at the way we implement reliable collections, you have to use things like run async or open async and handle tasks or callbacks in a specific way. So sort of what we're hoping in the future is that the experience with reliable collections is more similar to an average data structure. So it doesn't matter that we've implemented a dictionary or a queue or a concurrent queue, or that we've implemented a hash map. It should just be like you've implemented a hash map, but it's like a hash map plus, where all of a sudden it has Service Fabric's replication under it,
Right.
which sort of allows you to take advantage of what we've built, and like the scalable part of it, the durable part of it,
Right.
without altering the way you think about your code.
Right.
Yeah. And that's cool.
That's cool. Really cool.
Yeah.
Right.
Yeah. And it's natural for someone like you who's a Java developer,
Right.
right?
Yes. Yes.
You want to get that natural experience and not have to learn something else because it's all we support.
Right.
Those days are over. And have a
Once you
wonderful
use
trip.
Service Fabric, you're going to have fun.
Yes, man. Hey, thank you. Have a wonderful trip back. Say hi to us, to our colleagues there that we don't see.
Yeah. Ronak and the rest of your team there.
Absolutely,
Yeah.
man.
Sure.
Safe travels, and we'll see you soon.
Thank you. Thank you.
Cheers.
See you guys.